There is something mysterious happening inside the sun. But to truly understand what that mysterious thing is, we need to have an understanding of some very important concepts in physics. So over the next 10 minutes or so, I am going to try to explain those concepts and eventually reveal that mysterious thing which is happening inside the sun. So let's begin. The first concept that we are going to need is that of what is meant by an energy barrier. So think of a wall, and there is a person who wants to jump over the wall. Now, depending upon the height and the width of the wall, mostly the height, there is a certain amount of energy that the person must possess in order to make it, in order to overcome the wall. Now, whenever we are faced with a situation where there is a certain amount of energy that we must possess in order to cross something or overcome something, that in physics we like to call it as an energy barrier. Simple enough. So the idea is this: if the energy is greater than that of the barrier, you jump over, and if the energy is less than the energy barrier, you get stuck, you have to stay there. The next concept that we are going to need is what really is meant by temperature. So if I give you two containers of gas, A and B, and if I make a statement that temperature of A is greater than temperature of B, what exactly does that mean? Well, you have to understand at the microscopic level, at the atomic or molecular level, all gas is a collection of particles, and it is moving, all the particles are moving with some velocity. They're different velocities, but you can measure an average velocity with which these particles are moving. So temperature essentially is a measure at the microscopic level of what that average velocity or speed is. So higher the temperature, higher is the average velocity with which these particles move. So when I say that something is hot, it means that at the microscopic level, the atoms or the molecules that make up that substance are moving around with a very high velocity. And if I say that a substance is at a very low temperature, it means the overall random motion or the velocity with which this motion is exhibited is very poor. The next concept we should be familiar with is the electromagnetic force. So there are two kinds of charges. There is positive charge and negative charge. And if you keep like charges together, that is positive and positive or negative, they repel. That is, they push each other away. But if you have unlike charges, that is, you have a positive charge and a negative charge, then they attract each other. Now, the laws of electromagnetism tell us that the intensity or the energy or the force with which this attraction or repulsion takes place depends on the distance. So if the particles are very close to each other, the force that they experience, either repulsion or attraction, is very large. But when they are further away from each other, they experience a lesser force. Great. Now the next thing that we need to understand is what we call a strong nuclear force. So on your screen, you can see a cartoon depicting the model of a helium atom. So at the center, you have two neutrons and two protons. So neutrons are not charged, but the protons, in this case indicated by the red spheres, are positively charged, and you have two electrons going around. Now, one question that you can ask is, these two protons are positively charged, which means they must repel each other. But clearly the helium atom is stable, which means it is not disintegrating, it is not breaking apart, which means that there is something even stronger than the electromagnetic force of repulsion, which is holding these protons together along with the neutrons. This is what we call a strong nuclear force. So, but the thing about the strong nuclear force is that it is only operational at a very, very short distance. So if the protons are really close to each other, then yes, the strong nuclear force will make sure they are always held together. But if you take these protons a little far apart, then the nuclear force is not strong enough and the atom will break apart. Now, we can ask the question, what is the process that is responsible for the immense production of energy in the sun? It happens to be a process known as nuclear fusion, and this is how it works. This is a very, very high overview. There are many details that I am not giving you, but basically what happens is that two hydrogen atoms are fusing together in order to produce helium. Now, if you measure the total mass that was there before the fusion took place and the mass that was made after the fusion took place, there is a difference. We find that some amount of mass has been destroyed, and Einstein's equation E equals mc square tells us that this mass can be converted into an associated amount of energy given by the famous formula E equals mc square. Alright, now here is the idea. You want hydrogen atoms, which are nothing but protons essentially, to fuse together. But we also know that protons have a repulsion to each other because of the laws of electromagnetism. We also know that the strong nuclear force is strong enough to hold these two together despite the repulsion. But for that, we need to bring the protons close to each other by a certain distance. If we can overcome the repulsion and bring these protons very close to each other, then the strong nuclear force can take over and fusion can take place. So here is the basic idea. Protons must have a minimum amount of energy so that they can come close to each other, overcome the repulsion and let the strong force take over. Now, in a sample of gas, like the sun is, the energy comes from motion, right? That is kinetic energy, as we like to call it. We have also studied that higher the temperature, greater is the amount of motion, and which in turn means if we need minimum amount of motion, we need minimum amount of temperature. Otherwise, fusion cannot happen. Now we can do the calculations, and it turns out that the temperature that should be present at the center of the sun is a whopping 10 power 9 degrees Celsius. But what is the sun's temperature? Now let's recall that 10 power 9 is the temperature we want, and all our measurements and physical models and other estimates show that the temperature of the sun is 10 power 7 degrees Celsius, which means that the sun should not even shine because the temperature is not enough for nuclear fusion to even take place. But clearly that's not true. This entire video has been shot thanks to sunlight. We are all alive thanks to sunlight. And so clearly fusion is happening. But how is that possible when the temperature of the sun is not enough? Now this is where we invoke a very dramatic concept of quantum mechanics known as quantum tunneling. So we all know that if the energy is less than the barrier, we expect that we will not be able to overcome the barrier. But quantum mechanics, which is the law of physics or the theory of physics that explains subatomic particles, tells us that the behavior there is different, and it allows for a process known as quantum tunneling to take place. So what is quantum tunneling? Well, it basically says that even if the particle does not have enough energy to overcome the barrier, there is a finite chance that some of the particles with less than required energy can tunnel through or break the barrier even though they don't have that energy. And that is something very mysterious. And it's called quantum tunneling, and it's a very, very fascinating concept. And we all like to think of where exactly is quantum tunneling useful. It just sounds like theory, but no. Our sun is powered by quantum tunneling. Without quantum tunneling, we would not have the grace of our sun, and we would not be here today. Hope you found that fascinating. Thank you so much.